Hello, everybody. My name is Ilari Ikävalko. I'm an architect from a company called Arkkitehtitoimisto Rosberg Ikävalko Oy. Very long name, and if you're not Finnish, you probably wouldn't catch much of it. But it's rather old company. It was founded in 1973. And nowadays I'm one of the main partners. And I was taking part in the occurred pilot as a main designer of justice or courthouse for Pori municipality. So it was a public project with courtrooms and office space. And we tested it within the Accord pilot project as an example of public building. So our project already had started, and we had mostly already built the model before the Accord pilot started. So in our company, we have been using building information models for years. I have been now 19 years at the company, and the whole time all the new buildings have been modeled. So the basic modeling techniques were already familiar to us, and also the building regulatory information data, which we tested in this pilot. The data itself was already familiar. We use it every time. The same data points are used every time when we apply for a building permit. But the purpose of the pilot was to test how to get the information into the model, and so that the people who are processing the building permits can read it directly from the model. And so we had to build the data structure for the regulatory information into the native model, and input the data, and then when we exported the BIM model, it was exported with the model. So that was one part of the pilot, and it was quite successful, although some of the data points have changed during the process. So by the end of the process, some data points were missing because they were redefined on the way. So, but the technique works, and it's not too much work. And then as an additional test, we also tested how to get CO2 calculation data, i.e. amounts of different building materials within the model, how to get that out of the model, and well, how to get it into the model, let's say, because that was our part. So we define the walls and other structures so that the different material layers are also exported and can be read by somebody who needs the data for CO2 calculations. Here is the IFC model of the building. This is IFC4, which was used in the pilot. And normally, when the pilot started, we still used IFC 2x3. And as you can see, it's a rather simple building on the outside, and we have all the building elements, walls, windows, stairs, railings, etc. Modeled, and also some of the text for the public to see what building is this. And I can show, we can get a section from the model. So also on the inside there are walls and windows and doors visible. And this is all normal. This is how we normally model. There's no difference actually for our normal process there. But then we implemented some data structures. So this is now unfortunately in Finnish, but here I have selected the building itself, and there are properties. So here is the regulatory information data, or some of it. So let's say here is owner of the building and the fire regulation class, and the purpose of the building, office building, and then there's some location data, and here are some of the regulatory information data that is normally not modeled, but these we added, and it includes things like what's the main facade materials, and what is the heating source of the heating, energy, and so on. And then it also includes the data of the designers who has designed this building. So now we are in ArchiCAD, our native modeling program, where we design the buildings, and here you can see the basically the same settings that we incorporated in the model. So this is the regulatory information. So here are information about the buildings, the owner, and fire classification, and the purpose or use of the building, and so on. Maybe I'll, well, and then here is the coordinates for the building, and more of the building information. Here's the facade material and the heating doors and so on. And finally here the designer data. And let's move this aside. This is what the model looks like in the native program. And here as well, if we, let's say, take the roof off, you can see things in the inside. Mostly ceiling panels in this case. And this is a general view of the first floor. This is how it looks like in the plan view. So our pilot project is pretty much finished in the real world, and so I have some photos here. This is the main entrance, and as you can see, the building process is still going on, but it's almost ready. And some the roof of the main entrance, and some photos from the inside. These are the courtrooms, or one of them, one of the meeting rooms, and this is for the staff room where they take their lunch and breaks, and then a photo of the main facade. Just to give you an idea of what sort of building we are talking about here. So for the most part, the pilot was quite successful. We tested the different modeling techniques and also the automatic testing on the model. So there are different rules that are applied to test if the model is correctly done, and we found some things to develop further, but this is mostly quite sort of on the other hand simple, on the other hand technical data. Let's say, for example, are the stairs correctly modeled so that they are not too steep, and so on, for the regulations, because for, let's say, fire exits, you need to have certain measurements in the stairs so that it can be used as a escape route and things like that. And we found that for our normal practice, we often model some of the more elaborate stairs with the sort of as a, with separate elements, so that we actually make the geometry ourselves. And that is a bit of a problem for these automatic rules, because for them to work, the rule has to first pick all the stair objects and test them. And if we model it as separate elements, it's not recognized as a whole called stairs, and the automatic testing becomes much harder, or maybe even impossible. So that was one thing we learned, that if there's sort of special geometry that has to be modeled, then it probably can't be automatically tested, and have to be communicated with some other way to the building permit process. And for doors and well, mainly the doors, very important thing is to put the properties of the door into the model correctly, so that fire doors are marked as fire doors and escape doors as escape doors. And when that data is correct, then the rules work all right. They can then check that the door is big enough and so on for the purpose. So what's the point of this all? Well, for building models, it sort of forces designers to implement correct data structures in the model. And as architects, we are often very visually orientated, and the main purpose of the model traditionally has been to model the geometry correctly, and that is sort of step one in the building information model, so that the geometry is correct. But this automatic processing of models sort of creates a checklist that you have to also correctly model the properties of the different things in the building, not just the geometry. And that's it's a bit of a learning curve, but for some parts of the process, but it definitely improves the usability of the end result, or i.e. the model, and also makes possible for these automatic checkups. And the other point is that when we move to the practice that all the new buildings are modeled by default, and the model is delivered to the permit process, then it also enables sort of automatic updating of the sort of city models, so that when a new building is made, it's in the correct position and correct geometry, and it's easy to incorporate it into the citywide digital models of the or mapping information. So you get these sort of more accurate digital copies of cities and towns at some point. Of course, it takes time, because it's not very often then a certain plot gets a new building or enough remodeling that it is rebuilt as a model. But anyway, that's the one of the long-term benefits.